Okay, so let me show you how to do this calculation of the pH of ammonia, quarter molar. Association expression, which would be the reaction of the ammonia with water. Again, HOH. What it leaves behind is ammonia with a hydrogen ion, which now becomes ammonium. And I also have a hydroxide left over. Alright, so I'm going to start with the ice table, ICE. Water's a liquid, we don't care about that. I'm going to put 0.25 molar here, 0, 0, plus x. I'm sorry, not plus x, but here it's going to be minus x. Here it's going to be plus x, and notice the pattern. Pattern is going to be the same general pattern we saw with the weak acids, which is nice, but it also can lead you to make a very, very common mistake, which I kind of already alluded to. Now, I've told you before to write the expression, which would be in the KB this time, and we're going to write the products over the reactants. Take the time to write this step. Remind yourself that you are not dealing with hydrogen ions, but you are dealing with hydroxide ions. As I said before, students that skip these steps tend to make more mistakes than those that put this step in. So now I substitute in x squared over 0.25 molar. I'm going to get rid of that x because the KB is so small. It's such a small KB I can drop it out. So 1.8 times 10 to the minus fifth. I can solve for my x, which is equal to the concentration of hydroxide, which is also equal to the ammonium, which I'm not really concerned about. And when I do that calculation, I end up with 2.12 times 10 to the minus third molar. Alright, so that is the concentration of the hydroxide ion. I can find the pOH of this by taking the negative log of my hydroxide concentration. And if you want, you could find the hydrogen concentration and then take the negative log of the pH. But I tend to like to do it this way. 2.67, and then to find my pH, I just do 14 minus 2.67, and that would give me 11.33. And there is my pH of a weak acid, in this case the ammonia at a quarter molar. Now, what does this mean? Think about this. Not only what does it mean, but just check your work. Think about this. If the pH is 11.3, does that make sense that it's a base? Yeah, because if its pH is greater than 7, then we know that we have a base, and that's what we want. We want the pH to be greater. A lot of students do this as the pH calculation because they don't bother. They just keep x, and then they just circle this as their final answer. You should know that's wrong. Because if it's a base, the pH should not be that low. It should be very high because pH higher than 7 is a base. Alright, so that's generally it. I mean, it really is not that much different than the weak acid problem. It's that the strategy is all the same thing we did in the last chapter as well, in the previous unit. So really, just the basic strategy is there. Just watch for the little nuances and just be careful of what you're doing with the base. Alright, I'll take questions in class, and I'll see you later, guys.